In this episode of Jonathan's World, Jonathan presents to you the results and conclusions of his summer research. This is basically part 2 of the video I just put up.
So here's some of the results I've got. So this is the result of the pitfall traps through all the plots, just generally what is available. And on the y-axis we have a log scale of abundance, and on the x-axis we have time, where so the first tick is June 10th, and the last tick over here is July 22nd. You can see three very interesting things in this graph. First of all, there's a wide diversity of things out there. We have Collembola, which are springtails, odonates, which are dragonflies, spiders, coleopteras, and hemipterans. And they're all in different abundances. The Collembola I've gotten in the hundreds every time I've gone out to sample, while the odonates were all below 10 in each of 10 every time I've gone out to go sample. Another interesting thing to see here is this big dip. I don't know if you've heard, but we've had a bit of rain this summer. Yeah, my pitfall traps kind of got flooded during this time, and that's why there's low invertebrate availability. A third thing to notice is that things really don't stay all that constant through time. So if you look at the hemipterans, the brown boxes, they start off low, and then they steadily increase over time. So the abundance of hemipterans was greater in the latter days of the summer than in the beginning. So this is also the pitfall data, what I got for spiders in each of my 4 different treatments. This is mean abundance for these treatments. And there's 2 interesting things to note here. First of all, in this plot where I wanted to remove spiders, I did depress the spider density. But in this plot where I also wanted to remove spiders, I wasn't as successful at lowering the spider densities. I'll explain why in a second. I have 2 hypotheses as to why this bar is so high. Okay, before I go on, so in actuality, it's very difficult to make a comparison where to say that both of the predators were removed in this treatment, because in actuality it doesn't really seem like the spiders were removed. So this treatment looks more like the Sarracenia removed treatment, where only the pitchers were plugged, but the spiders weren't necessarily removed as much as I would have liked. So for the odonates, these are dragonflies. We have some very interesting data. When we remove spiders or Sarracenia, the numbers are about the same. But when we leave them both in the environment, the numbers go way down. This could suggest that they're both preying on the odonates, or it could suggest some type of complex interaction going on, where they're both around. Perhaps some hunting spiders or something are lowering the odonates down because they see that there are more spiders around, or because it could suggest complex interactions, this graph. But when we look at the true bugs, the hemipterans, something else interesting happens. When we remove spiders, there's a huge spike, at least 2 times as much as any of the other treatments. This could lead one to believe that the spiders are selectively preying on hemipterans, because when they're removed, the hemipterans, the hemipteran availability spikes up. But it gets kind of confusing, because when we remove Sarracenia, the hemipterans go down. So why would the availability of hemipterans go down when you remove a predator? So the conclusion is that we may have niche partitioning for hemipterans, or we might have more complex interactions when we looked at the dragonflies, and also with the hemipterans with respect to the Sarracenia data. One possible explanation is intraguild predation. It doesn't fully explain everything, but intraguild predation basically means that the Sarracenia and the spiders are competing with each other for these invertebrate prey, but the Sarracenia also preys on the spiders. So the spider is also considered food for Sarracenia. Now when we go back to the spider plot, this kind of makes more sense. When I only removed the spiders, I was removing spiders, but also I didn't do anything to the pitcher plants, so they also were removing spiders for me. But when I removed both, the pitcher plants were not helping me out, so that could possibly account for this. Another possible explanation could be that as I removed the web-building spiders, other hunting spiders might have been moving in, and they could be what I'm seeing here. So there's also more evidence for intriguing predation. I had 82 cases from the pitcher extraction of spiders being caught in the pitcher plants. So this relationship might be a lot stronger than I had thought going into this project. I'd like to thank everyone who helped me collect data this summer. A lot of RU students came out with me. And I'd also like to thank Kate Bennett, who was there most of the time this summer while I was out there. It was hard work going through that bog. Jane and Jim from McNair, Aaron, Allison, and Clarice here at Harvard Forest, and Nick Catelli at University of Vermont. Any questions?
So we were saying that you had instances of spiders being predated on by the pitcher plants. Were these the hunting spiders actually moved around, or were they also?
I still have to look at that, but a lot of them seem big. I'm guessing they might have been the hunting spiders. Yeah. Yes.
When you were saying you were removing them by hand, were you just removing hunting spiders? Or
I was removing the web building spiders. Okay. Yes.
I was wondering if there's any kind of mutualism, where the pitchers are attracting insects towards the spiders. Do you see anything there?
I really haven't considered that. Yeah, I don't really think so, but
Did your pitcher collections or your oh, never mind.
Yes.
The dragonflies, were you mainly capturing larval dragonflies?
Yes.
I can't imagine like a whole freaking dragonfly getting stuck in a pinball trap. Yeah.
You'd be surprised. I did get 2 or 3 adults, but yeah, they're mostly larval dragonflies.
Okay, that makes sense, yeah. So we have time for one more.
Yes.
But about the mutualism, I remember it was either your talk or Professor Alvin's talk. You mentioned that sometimes, I don't know if it was web building spiders or hunting spiders would lower themselves into pitcher plants.
Some web building spiders
Yeah.
build their webs over pitcher plants. Yeah, and that could suggest that there's a mutualism going on, but I don't see how that would benefit the plant. It's basically the spider taking the food out of the plant's mouth.
Thank you so much, Jonathan.
Also, you should comment down there, and that way you should probably subscribe. And if you like the video or the information presented, give it 5 stars. Just rate the video. All right. See you later. Jonathan's World. Bye.